Okay, I'm doing a quick recording for Carol in Missouri, who has a fifth grade daughter, and she's doing some word problems that have to do with fractions. And we're going to talk about repeated addition and parts of numbers in these two. So, Carol, these are for your daughter or your son. I hope this really helps. So in the first two problems, I'm going to start with the easier ones first, and the next two are going to be a little tougher because they're more conceptual. So in this first one, Jackson is in a swimming pool that is 20.5 meters long, and he swims 4.5 laps. How much did he swim? So I'm automatically thinking of the pool, and it's 20.5 meters. And what is he doing? He's swimming one lap, then Jackson comes back, then he swims another lap, he comes back, and he swims halfway through another one. So I could think of this as he's doing 20.5 plus 20.5 plus 20.5, and I'm getting the same number. Or I can just think of this, if I'm repeatedly adding, then you're going to automatically think of multiplication. This is any time you have repeated addition. So if you're repeating the same number again and again, we're just going to multiply them. All right, so I'm going to erase this for a second to give us some room. Let's make it a little bigger. So I have 20.5 times 4.5, because he swam it 4.5 times. And I'm going to change these to a mixed, from mixed and proper. So I'm going to do a little loop-de-loop, and I'm going to multiply first, and then I'm going to add. Okay, so I'm going to start by putting this 2 here, and then I'm going to do 20 times 2, which is 40, and 40 plus 1, which is 41. And I do the same thing over here. 4 times 2 is 8, plus 1 is 9. All right, and that's going to give me 369 over 4. Now, as you can see, none of these numbers are that look like this. This is an improper fraction. So when you see this, think of division, because you could even see the division sign is here. That's what this is. And a lot of kids mess up and they're not sure which one goes inside. So just imagine when you have little kids running around the house, if they hit this table, boom, this is going to fall right over. And that's exactly what happens. This number falls into the house. You could also have kids who say it from top to bottom. 369 is being divided by 4, if that really helps. Okay, and now I just do my regular division, which should be okay at this age. And they end up with 1. My remainder is 1, but they don't write remainder as 1. They write 1 out of 4, because they need 4 to make the whole thing. And you can see that that answer is right here. Okay. All right, so I'm going to make that smaller again, and we're going to go into the next problem. I'm just going to delete this, just that little part, just so you can see. But yeah, so you can kind of see where I got it. All right, in this one, there's a sack of potatoes that weighs 4 2/3 pounds, and there are 20 sacks in a crate. All right, so automatically I'm thinking of a sack potatoes, and it weighs 4 2/3, and I have 20 of them in a crate. So again, you're thinking I have another sack and another sack and another. I have 20 of them, but they're all going to have the same number. So again, repeated addition. So I'm just going to multiply. So I'm just going to do 4 2/3 times 20. I'm going to put over 1 because we need a second number to multiply. All right, and in case so you notice, it's always multiplying straight across. That's why I needed this one there. I'm going to do the same loop-de-loop over here. So I'm going to loop 4 times 3 is 12, plus 2 is 14, times 20 over 1, and I have 280 over 3. Okay, same thing as before. I see 280 divided by 3, so I'm going to do that. Remember, the 280 falls into the house because the little kid knocks it over. He always knocks him down into it. And now when I do this, 3 goes into 28 9 times. 9 times 3 is 27. And I get 10. 3 goes into 10 3 times. That's 9. And I have a remainder of 1. So 1 out of 3, which happens to be right there. If you're stuck on how to remember the steps for division, boys like, my boys used to say the saying, dead monkeys smell bad. Dead monkeys smell bad. Divide, multiply, subtract, bring it down. My girls used to do a little dance. They used to go do a dab, a midi rock, shake it down, bring it down. They used to just do all these different types of dance moves to remember DMSB. So that's just a step strap. Okay, so anytime again, if you're repeatedly adding the same number, you just multiply. That's the first time we're going to see that. These second ones get a little bit difficult because now we're going to talk about parts of numbers, and we don't always think of this as multiplication. So again, when we want a part of a number, we can multiply. So let's see what this looks like. In this one, we have a bike race is 3.1/5 miles long. So he's going 3.1/5 miles, but he gets a flat tire. Oh no, 2/3 of the way there. So I'm going to kind of cut this. So if he was doing this race, he got through, he did, I was trying to shade it in. He did this part and he did this part and then he got a flat tire. So I want to know how much this part is. So really what I'm asking is, what is 2/3 of 3.1/5? That's what I'm actually trying to figure out. So I'm going to show you kind of short. I'll show you the fastest way. Anytime I want to know a part of a number, when you see this of, just think multiply. Okay, I'm going to show you how in the next problem so it makes sense. So you're really doing 3.1/5 times 2/3. We're going to change this again into an improper fraction by 3 times 5 is 15 plus 1. And we're going to leave the 2/3 here. And so I'm getting 32 because 16 times 2 is 32 over 15. And again, you could automatically see like this is too big, so boop, it's going to go into 32. We're automatically going to do that. So 15 goes into 32. 15 goes into 30 times 15 goes into 32. 2 times, so you get 30. And you get 2 left. 2/15, which is right here. I'm going to show you why this works in the next problem, because there's a concept part that's here. So if you're not getting why, just hold on a second. And if you don't care about the why, you can just watch these problems and just stop at that point. So here, same thing. A team of runners is doing a relay race that's 9/10 of a mile long. And Carl runs 3/5 of the race. And his team, how far did the team run? So again, Carl ran this part, and this part, and his teammates ran these two parts. And we want to know how much did his team run. So I want to know what is, I want to know what is 2/5 of 9/10. Why? Because I want to know what the team ran. That's why I'm putting the 2/5. So I'm going to do 9/10 times 2/5, and I get 18 because 9 times 2 is 18 and 10 times 5 is 50. I'm going to simplify this because both of these have a factor of 2. So I can divide both of these numbers by 2. So 2 over 2. We call that property of 1. And 18 divided by 2 is 9. And 50 divided by 2 is 25. So now this is in simplest form. I can't simplify this anymore. Now, if that's all you really, if this satisfies what you need, fine, we'll stop here. But if you need more concept building, I'm going to tell you why this works over here. All right. So if I want to know, I'm just going to think about it for a second. Here's 9/10. Here, I'm going to break it up into 5 pieces. They're definitely not to scale because they're not, I kind of like them the same size because I get a little crazy about those little things. So let's try and make them close to the same size. Okay. Here's the tube that the friends ran, and this is what Carl ran. What I could do is kind of think of, well, like a candy bar. I can break this candy bar into 5 pieces. When I break something into 5 pieces, I'm thinking of division. So what if I divided this into 5 pieces? Divided it by 5. I'm not sure if your kid knows division yet with fractions, but we do something called keep, change, flip. In other videos, I actually explain why. So I keep this first number, I change this to multiplication, and I flip the second one around, and I get 9/50. that means that each of these is 9/50ths. And you might go, Sarah, why? When I add all of them up, I get 9, 18, 27, 36, 45. So if I added them all up, I would get 45/50, which does simplify. I can divide both of these numbers by 5 into 9/10. So you see, it does match. So this total is equal to this, okay? So that's how much these pieces are. So if you want to know what the friends ran, I only want these two. So if each piece is this, I can just multiply it by 2 and get 18/50ths, which again does simplify to 9/25. Okay, so this is kind of like the long way about it where concepts matter. But if I want that same number, all I really have to do is, instead of dividing the whole thing by 5 and then multiplying. So remember, that's what we did. We divided the whole thing into 5 pieces and then we multiplied it by 2. I can see those 2 steps actually right here. I am dividing it by 5 pieces because this is where my 5 actually happened. And I am multiplying up here by 2. So I'm multiplying those 2 parts. And then I had to just divide anyway because I have this 5 over here. It's all kind of hidden in there. So this is just making it quicker, is to just multiply it by that original fraction. Okay, so I really do hope that this helps you, Carol. And again, this is just a big concept part, but I'm going to tell you, if you want to know a part of a number, just multiply. If you're doing repeated addition, you multiply. And that's all your kids' homework is about. When do we use multiplication with fractions? If you have other questions, as always, you can email me, send me pictures just like Carol did, and I will be more than happy to help.